All right, we're talking about comparing and ordering fractions, Section 5 of Chapter 4. Section 5 of Chapter 4. All right. We're going to talk first about comparing fractions. Okay. To compare fractions, you must make two equivalent fractions that have the same denominator. Okay, so for example, if I have the fractions 11 over 15 and 2 over 3, okay, and they want to know which one is greater. Okay, they want you to use the less than, greater than sign, equal than sign. You've got to convert them to have the same denominator. So that means I'm going to take 11 over 15 and 2 over 3, and we call it the LCD, the least common denominator, also known as the LCM. Okay, LCM is the least common multiple. Okay, so what they want to know is what is the least common denominator, also known as the LCM, of 3 and 15. In other words, if I was to count by 3s and I was to count by 15s, which number do I run into first? Huh? So count by 15s. 15, 30. So how do we run into a 3? We don't. I know. No, listen to what I'm saying. Don't think what about I'm saying. Listen to what I'm saying. Okay? I am asking you for the least common multiple, also known as the least common denominator, between 15 and 3. What is that? No, I'm not going to repeat it because I've written it on the screen and I've said it 3 other times. Haley? Okay, count by 15s. So when did you run into 5? Copeland? It's 15. When you count by 15s, 15, 30, you count by 3, 3, 6, 9, 12, 15. 15 is the first number that's common between the two that you run into. So 15 is going to be our common denominator. So I'm going to create a fraction, two fractions with 15 on the bottom. Now, here I took 11 over 15 and I converted it to 15 something over 15. Well, I multiplied by 1 to the bottom to get it to 15. So I must do the same thing to the top, which makes that 11 over 15. Okay, in other words, I multiplied by 1 here, so I have to do the same thing. If I do not do that, then the two are not equivalent, as we learned in Section 2 of Chapter 4. Okay, now I need to say, okay, what did I do to 2/3 to make it to have a bottom number of 15? Okay, I multiplied by 5. So I multiplied by 5, so I do the same thing at the top, and that gives me 10. So, now that the denominators are the same, which is larger, 11 or 10? Okay, 11 is. So therefore, in my blank goes the greater than sign.
What's the thing, what is the least common denominator? What's that? Is it
LCM. Yeah.
So the greater sign is
Huh?
so that, alright,
The greater than sign is what goes in the blank. Okay, let's look at another example. If I have 15 over 56 and 2 over 7. Okay, now if I don't know what the least common denominator is between 56 and 7, then I do what we did last night. I prime factor it. 2, 28, 2, 14, 2, and 7. Okay, well 7's already prime. 7's already prime, so I don't have to prime factor it. I just bring it down. So I have 7, and I have 2 to the third times 7. Well, the prime factors that were used are 2 and 7. So I have 2 to the third, but no 2, so I use it 2 to the third. I have 7 to the first and 7 to the first, so I use it 7 to the first. And that would be 8 times 7, which is 56. So the LCD is equal to 56. So my new fractions are going to have 56 on the bottom. No, not now. I'm moving on. Now, so as we look at the fractions, the new fractions of 56, then we must ask ourselves, what did we do to 7 to make it 56? By 8. So I do the same thing to the top. I multiply by 8. That gives me 16. Then we ask ourselves, what did we do to 56 to make it 56? Multiplied by 1. So we do the same thing to the top, which makes that 15. Now, raise your hand. Copeland? Huh? Last year? Yeah, but everything we've done up to this point we did last year. So, that's why it shouldn't be new to you. Madison?
But I thought it would make 56 out of 15.
No, I did not change 15 to 56.
No, I thought if you put what equals 56. Yeah, like you did 7. Yeah.
I did.
Why didn't you do what? No,
I did. 1 times 56 is 56. But, okay, now listen, hush, y'all hush, let me explain. This number right here that I multiply by has to be equal to 1. Just like over here, it was 8 over 8. Okay, up here, it was 1 over 1. Right here, it was 5 over 5. Okay, so that has to be equal to 1. So I do the same thing, whatever I did here, I must also do there. If I don't, then it's not the same fraction. It's a totally different fraction. That would be like if I had 2 large pizzas and there's 8 slices in both of them, and I divided one in, cut each slice in half, and then I cut each slice over here in thirds, then there's more pizza over here than there is over here. Okay, and so that's not the same. You're not making equivalent number of slices. Okay, just like here, we're not making equivalent fractions. I can't multiply that by, let's say, 5 over 1. You can't do that. If you do that, then you no longer have equivalent fractions. You have a totally different fraction. And so you can't do that. No, you're being distracted. No, stop. Okay, out in the hall. Done. Talked about this yesterday. Not doing it. Out in the hall. Go sit out in the hall. All right. Now, this one, 5 over 24. And 1 over 6. Okay, I want you to do this one on your own. Okay, I want you to come up with a common denominator, and I want you to convert the two fractions to the new common denominator. So the common denominator is 24, so what were your new fractions, Gracie?
5 24 and 40.
Okay, 5 24ths and 4 24ths. So which one is greater? 5 what?
5.
Okay, so the greater than sign goes in the blank. Remember, this sign is greater than. This sign is less than. Obviously, that sign is the equal sign. Okay? Now, remember, what I've said for the last 2 years, the less than sign points to the left. Okay, the greater than sign points to the right. Okay, so if you're asking or you're just, obviously if we're not seeing it in front of us, sometimes we get confused with it. Okay, now, so, as I stated before, if you don't know the least common multiple, most of these you should be able to see what the least common multiple is just by the two numbers that you're looking at. Okay, for example, they may give you a fraction over 9 and a fraction over 36. Okay, well, what would the common denominator be between 9 and 36? What? Okay, you're going to have to open your mouth like you do when you make your little noises in class. Open your mouth and actually speak. 36, thank you. See how that worked? You opened your mouth and it came out instead of no. Okay? Now, that's comparing fractions. Let's look at ordering fractions. Okay, we're talking from least to greatest. Okay, we're talking from least to greatest. Now, here are our fractions. 3 over 8, 9 over 32, 1 over 4, and 5 over 16. So, same thing here. We must have common denominators to order the fractions. Okay? Now, obviously, we've got to have a common denominator between, our common denominators be between 8, 32, 4, and 16. Huh? Is 30. See, okay, let's practice what Copeland, I told him to practice. Open your mouth. Your teeth don't have to be together to talk.
Sometimes people can't open their mouth.
Oh, trust me, it ain't any of y'all.
What?
All of y'all don't have any trouble opening your mouths. So what did you say, Gracie? Thank you for speaking it clearly. And you still didn't open your mouth. All right, the common denominator is 32. Now, if you could not see that, okay, if you couldn't see that, I count by 8, 16, 24, 32. I count by 4, 8, 12, 16, 20, 24, 28, 32. Count by 16, 32. Okay, then you would have to prime factor them, and you would have to find the least common multiple between the four numbers. Madison?
I thought the numbers can be one of the bottom numbers.
No, it can, and it doesn't. It does not have to be one of the bottom numbers. For example, if that was 9 over 2, okay, 9 over 2 would change things. It would change it to 16 would be your common denominator, okay? But since it's 32, then we've got to use 32. So we're going to create 4 new fractions, all with the denominator of 32. Okay? Now, what did we do to 8 to make it 32? What do you have to multiply 8 by to get 32? By 4. 4 times 3? 12. So it's 12 over 32. 32, we didn't have to do anything to, so I just bring down the 9. Okay? What did we do to the 4 to make it 32? Times 8. Do the same thing at the top, makes it 8 over 32. Now, what did we do to 16? Multiplied by 2. So that's, whoops, my bad. Should put 2 there. 10 over 32. Okay, now, here's the part where people mess up. Okay? When listing the fractions in least to greatest order, you must list the original fraction in the answer. Okay, so as we're looking at it, we are not going to list these fractions in your answer. We're going to list the originals for our answer. So, as we look at this, 8 30-seconds, 9 30-seconds, 12 30-seconds, and 10 30-seconds. Which one of those fractions is the smallest? 8, 9, 10, or 12? 8. So the 8 belongs to 1/4. So I'm going to put 1/4 first. Okay, what's the next smallest? 9 30-seconds. So I'm going to put it next. Okay, 10 30-seconds, which is 5 over 16. And then 3/8 is the largest. Do what? Sure? Okay. All right, so that's in least to greatest order. Okay? Let's look at another one. Um, 17 over 81, 5 over 9, 13 over 27, and 2 over 3. So, as we look at our denominators, 3, 27, 9, 81. Common denominator is what? 9. Okay, stop. Okay. Count by 81. 81, 162. Never ran into 9. 9 is a factor, not a multiple of the numbers. Cannot be 9. Okay, 27, 54, 81. Can't be 27. 81 is the common denominator. 81 is the new denominator. Now, once again, if you can't see that, you can't see it, then you have to come over here and you have to prime factor each of the numbers. Then you have to prime factor 9. You have to prime factor 27. Then you have to prime factor 3. It's already. So that shows you 3 to the 4th, 3 to the 2nd, 3 to the 3rd, 3 to the 1st. The only prime numbers that were used was 3. I had 3 to the 4th, 3 to the 2nd, 3 to the 3rd, 3 to the 1st, so I got to use it 3 to the 4th. 3 to the 4th power is 81. That's where I get the 81. If you don't see it, that's how you have to do it. Okay, that way works every single time. If you do the math right, obviously. Okay, now, so what did we do to 81 to make it 81? Times 1. So we do the same thing to the top. That makes it 17. Copeland, what did I do to 9 to make it 81? So I do the same thing to the top. Juliana, what I do to 27 to make it 81? What? What'd you multiply by? What'd you do to 27 to make it 81? What'd you multiply by? Huh? You have to multiply it by something to make it 81. To go from 27 to 81, what did I do?
May I have your attention, please? Just want to remind everybody we've got a big volleyball game tonight. It's the first round of the playoffs. We want to encourage all of you to come and see our volleyball team play tonight. I just confirmed students are free for the game tonight, and staff is also free. Parents, people that normally have to pay would still have to pay. So anyway, we do want to invite you. We just hope to have a whole bunch of people there to cheer the kids on. So come on out.
Gracie, what did I do to 3 to make it 81? 3. Juliana already answered that during the announcement. Okay, multiplied by 27. Okay, so that makes 54. 2 times 27 is 54. So, as I look at those fractions then, I have 17, 45, 39, 54. Which would be the smallest? 17. So I put 17 over 81. So what is next? 39 over 81, which was 13 over 27. 45 over 81, which is 5 over 9. Then the last one, 2/3.
Can we list it from the 11 or 17 over 81, 39 over 81? No. Can we list it on that?
That's why I said you had to have the original fractions in your answer. Yeah. For example, if you had 3/4, then you're going to have to, the only way you're going to be able to do it is you're going to have to prime factor it, and it would normally, if all of those were the same, and let's say we just changed 2/3 to 3/4, okay, then what you're going to have to do is you're going to have to end up taking 81 times 4. So it's going to be 324. So they won't, most of the ones they're going to give you are not going to have that. They're all normally going to be a multiple of the numbers you're looking at. Now, the other thing, and that leads me to my other point that I'll come back to. It is. No. 17 is over 81. Okay? 17 over 81 is this fraction right there. 2/3 is that fraction, 54 over 81. 54 over 81 is larger than 17 over 81. So you can't just do it by, for example, I can give you 100,000 over 1 million. Okay, but 5 over 6 is still bigger than 100,000 over 1 million. It doesn't matter. It doesn't matter how big the numbers are that you're dealing with in the fraction. It's what happens when they both have the same number. Because, like, for example, I'll just use that. That's a simple example I can show you. If I had 100,000 over 1 million, and I was comparing that to 5 over 6. Okay, well, they don't have common denominators, but I know what the common denominator is. The common denominator is 6 million. Okay, and so you would have 6 million down here, okay, and that would be over, I multiplied by 1 million, so that'd be 5 million. And over here you would have 6 million, and that would be over 600,000. Okay, so now that they're in like terms, this fraction looks bigger, but the problem is the larger the bottom number gets, okay, and this one doesn't really get bigger, then the smaller it becomes. For example, 1/2. Okay, 1/2 is half of something, right? But if I change that 2 to a 3 and do nothing with the top number, now it's 1/3. Now it's smaller. Then you take it to 1/4, it's even smaller, 1/5, even smaller, and it just keeps getting smaller as the denominator increases, okay? So when we're over here, that 81, just because that's 81 doesn't mean it's larger, okay? This right here, 2/3, that's only one away from its denominator. So that's a pretty big fraction. Okay, for us to have the same type of fraction over here, this would have to be something, let's see, what do we say, 27, so that's going to have to be, this is going to have to be like 56, 50, actually more than that. It's going to have to be in the 60 range to be close to this. Okay, for that one to be close, this would have to be like 60. Okay, and so, it doesn't matter that the fraction has a bigger number on bottom. It's the overall fraction, how close the top number is to the bottom number. Nicole? I just said, what did I do to 6 to make it 6 million? I multiplied by 1 million. And so you multiply this by 1 million, multiply that by 1 million, and that's how I got 5 million. Here I said, what I do to 1 million to make it 6 million, multiplied by 6, 6 million, multiplied by 6, 600,000. And so obviously 5 million, that's how I do all the fractions. That's what I've been doing. That's what all these are right up here. All this right here, that's what that is. I did the same thing. I just wasn't dealing with those big of numbers. Okay, now, I want to talk about one last thing, and that is approximation. Okay, I want to talk about looking at fractions just sort of like we were talking about, and this comes back to what you were sort of talking about. 9 over 17 and 8 over 16. Okay, 8 over 16 is close, or is not close, is 1/2. Okay? So, what is 1/2 of 17? Raise your hand, please. Don't start calling out answers. What is 1/2 of 17, Gracie? What is half of 17? Yeah, there is. Every number has a half. Yeah. Vivica, 8.5. Okay. So, if 1/2 of 17 is 8.5, so is 9 larger than 8.5? Yes. So this fraction here is larger than a half. So if 9/17 is larger than a half, and 8/16 is a half, which is the larger fraction? If 9/17 is larger than 1/2, and 8/16 is 1/2, which is the larger fraction? What? 9/17. 9/17 is the larger fraction. Okay? Now, the reason you want to know approximation is because for me to find out the common denominator between 17 and 16, I just have to multiply them together. Then you're going to be dealing with large fractions. So I can look at that and I can approximate it that way, and that way I don't have to do the common denominators. You can do the same thing to this up here. As you look at 3/8, okay? 3/8 is close to a half. Is 1/4 close to a half? No, it's not. Okay? So you would know 1/4 is smaller than 3/8 because it's not close to a half. Because half of 4 is 2, it's sort of different. But approximation, let me give you another example. 10/21 and 15/28. Okay, well, what is 1/2 of 21? Now, what is half of 21? No? 10.5. Okay, so half of 21 is 10.5. What is half of 14? Okay, is 7. I gave you the answer. What is half of 28? What is half of 28? No, 14. Okay, so this is larger than 14. So 15/28 is larger than a half. This is smaller than 10.5. So 10/21 would be smaller than a half. So the larger fraction is 15/28. Okay? And that's how you can use approximation. Usually, they're going to cut the fraction in half, or they're going to cut the fraction in fourths, something that's very easy to see. Okay? So, your homework is this. The homework is 4.5, 2 through 24. All. You can, and you'll get a 50 if you get them all right. I think that would probably be best, Smart Aleck.